Good morning. I am Arul Jothi, working as Assistant Professor in the Department of Computer Science, Fatima College, Madurai. Today, we are going to discuss some basic concepts in operating system, mainly deadlocks. So, what is deadlock? So, how is it occurs? Deadlock is occur when a process requests a resource that is already assigned to another process, and it is waiting for a resource that will never be preempted. So we are going to see what are the various possible ways the deadlock occurs, and how to avoid it, detect it, and prevent it. So next we are going to see some real examples and cases how deadlock occurs. So deadlock example, one real example is when two trains approach each other at a crossing, both shall come to full stop and neither shall start up again until the other has gone. The same is the example in our cases. Two processes exchange a long message with each other, but their socket buffer is smaller than the message. So here is the diagram illustrating the sequences, process A and process B with a long message shared between each other. Second example is a bridge crossing example, traffic only in one direction, where two cars are driving from the opposite direction. A deadlock is not resolved unless one gets backup. So likewise, with the process and resource example, two processes try to go into the same nested critical section in a different order. That is, we are considering two processes P0 and P1 and a waiting stage A and B. Alternatively, A waits in P0 processor and B waits in P1 processor. So this is an example of a deadlock occurrence state. Next we are going to see the system model, which consists of several processes and set of resources. Here we are taking resource types R1, R2 till Rm, and each resource type Ri has several instances. Here we refer that instances as Wi. Each process utilizes a resource as follows: request, use, and release. So one process requests a resource, another process is using that resource, and after finishing that request, it releases it. So these are the sequences which goes on between the process and the resources. So deadlock can arise in four conditions, mainly mutual exclusion, hold and wait, no preemption, and circular wait. So in mutual exclusion, only one process at a time can use a resource. That is, mostly we have to use non-shareable resources. Hold and wait. The process holding resources is waiting to acquire additional resources that is held by another process. And no preemption. A resource can be released only voluntarily by the process holding it upon its task completion. Next one is circular wait. There exists a set of processes P0 of waiting process such that P0 is waiting for a resource that is held by another process, that is P1, and P1 is waiting for some other resource that is held by some other processor. So if this continues, that forms a cycle which leads to deadlock. So these are the conditions where deadlock can arise. So we have to avoid some situations holding this characterization. Next we are going to see the resource allocation graph. How we are going to allocate the resource corresponding to the process request. Here in the resource allocation graph, there is two categories. One is the process and another one is the resource. So the process is here represented as a circle and the resource as a square. Here P equal to P1 to Pn set of process and R equal to R1 to Rm a set of resources. In the resource allocation graph, we have two edges. One is the request edge and another one is the assignment edge. So request edge, if a process requests a resource, that is known as request edge. So it is otherwise known as directed edge. Assignment edge. So in the assignment edge, one resource is allocated to the process. Here allocation is done. The resource is assigned to the process. Whereas in the previous request edge mode, the process requests a resource. It is requesting only, but when the resource is free, it will be assigned. So next, so these are the categories we are going to see in resource allocation graph. So process, PI in a circle mode, and resource type with 4 instances. For a particular resource, we have 4 instances. So it is represented by a square with 4 black circles and a sequence of requests. If PI requests an instance of RJ, then a directed edge is requested edge is shown, and another one, next one is assignment edge. If a resource is allocated to a process, then the assignment edge is shown. So this is the resource allocation graph, and here is one example in a resource allocation graph where we predict a cycle. Here a cycle is formed in the P1 requests R1, and R1 is assigned to P2, and P2 again requests R3, which R3 is again assigned to P3, and P3 requests R2, and R2 is assigned to P1. So this forms a cycle, and so deadlock is possible here. And another example in this again R2 is assigned to P2, whereas P2 requests R3, and R3 is again assigned to P3, and P3 requests again R2. This also again forms a cycle. So in this allocation graph, 2 cycles are formed. So with the help of this resource allocation graph, we can judge whether a deadlock can occur or not. So here is a resource allocation graph with the cycle but no deadlock. Since this second one, R2 resource, has 2 instances, so R2 is assigned to P1, but it is also assigned to P3. So it does not form a cycle since it has 2 instances. If only one instance is there, the deadlock can arise. So next we are going to see the methods for handling deadlocks. So here in methods for handling deadlocks, we are going to see first the prevention and avoidance methods that we are going to follow to avoid a deadlock. Next, after deadlock occurs, we go to the detection and recovery state. And the third one, we have to ignore the problem if the deadlock occurs, and we can proceed with the next processes. So deadlock prevention. So already we have seen the characteristics that that leads you to a deadlock. There is mutual exclusion, go hold and wait, and no preemption, and then circular wait. If we avoid all these situations carefully, then we can prevent our process from deadlock state. So you should not use not shareable resources, and we should not allow the system to get into a cycle. So we have to check whether it is in a safe state or in an unsafe state. If it is in a safe state, means then deadlock will not occur. If a system does not form a cycle, then it will not lead to a deadlock state. So there are two type of states. One is safe state and another one is the unsafe state. The system is in a safe state only if there exists only a safe sequences. So any process that is requesting a resource should not be assigned to another process. Then it will be in the safe state. So a deadlock will occur only in the unsafe state. So these are the 2 states. So we have also some algorithms for avoiding and detecting deadlocks that we can see in the next session. Okay, thank you girls.